All right, so here we're going to be going over the power rule. So the power rule is going to deal with logs that have m raised to some power n, right? So different than our quotient and our product. All right, so if we think of the power, if it's an integer, really just a positive integer for now, right? Then we can think of this as we have n factors. All right, and if we had m factors, so if I had something like this, and I can write it as m factors, well then I can do repeated use of the product rule, right? And here so to make it general, log base b, so it could be log base b of m plus log base b of m, etc. All right, log base b of m, right? And here we have n terms, right? I can do that n times because that's how many factors we have. Well, these are all like terms, so if I add these all up, I put the coefficient in front of them would be n times log base b of m. All right, and as it turns out, right, this rule applies to negative exponents and even rational exponents, right? Fractions as exponents, right? So our product rule, excuse me, our power rule is going to be this right here, right? So whenever I have an exponent, I can just bring that exponent, and that now becomes the coefficient of my logarithm, right? So for some examples here, right? So if we have, let's say, the natural log of x squared, this is equivalent to twice the natural log of x. Right, so that's a neat little property. We can just bring that exponent out to the front. Now, in some cases, right, the exponent isn't quite, you're not quite sure of the exponent just yet, so you can do the natural log of 1 over x squared. And you can actually think of this as approaching it two different ways, right? Now, using the power rule, I could say, all right, well, the reciprocal is this is equivalent to x to the negative 2. Right, and now using the power rule, this is negative 2 ln of x. Right, so that's one way to think of this. But also, if I start here, I can think of this as a quotient, right, where we have ln of 1 minus ln of x squared. But natural log, or any log of any base of 1, that's 0, so that goes to 0, and then here, bring this in front. Right, now we use the power rule here, and there, we are back to where we got in the previous answer. Okay, so just keep that in mind, right? So there's more, right? These rules are very rigorous, right? So it shouldn't be a surprise that these work, right? These have been tried and true. Now, in some cases, like let's say we have log base 2 of, let's say, the square root of x cubed. So here, when we have a root is nothing but a rational exponent, right? Since this is a square root, I can write this as log base 2 of x cubed raised to the 1/2. Right? If it was a cube root, it'd be 1/3, fourth root, 1/4, etc. Right? And now using exponent rules, we get log base 2 of 3/2. Excuse me, x to the 3/2, and now we can apply our power rule, log base 2 of x. And there you go. And that's how we apply our power rule.